In this video, we will talk about the row equivalent matrices. So, if we have two matrices A and B and their order is same, you have two matrices A and B and their order is same, then they are called row equivalent if either of A and B is obtained from the other matrix. But through elementary row operations. What does that mean? You have two matrices, the one is A, the other is B. If one of these, for example, if A is obtained from B, but after applying row operations, if it is possible for A to be obtained from B after the application of row operations, then we say that A is equivalent to B. And it is very obvious that if A is equivalent to B, then B must be equivalent to A, because if A is obtained from the row operations applying on B, then B can also be obtained from A after the application of the inverse row operations. Okay? So two matrices are called row equivalent if both can be obtained from each other through elementary row operations. Here is an example. So, if the following matrices are row equivalent, so if the following matrices, so let's say the matrices are A is equal to this and B is equal to this. So if the following matrices are row equivalent, then find X and Y. Here is the solution. We are given that two matrices are row equivalent, then we have to find X and Y. Since both matrices are row equivalent, so that means each matrix can be obtained by the other one through elementary row operation. So let's start this from A. So we start applying row operations on A, and then we will try to get this matrix B. So here we have A. Okay, let's focus on B. Here we have B, okay? So, we will start from A, we will try to get B, okay? We will try to get this matrix B. Okay, you can check this entry and this entry, they are different. So, I have to make the first entry 0, okay? And look at the second entry. The first entry of the second row are the same, and the first entry of the last row are again different. So I will use this row, this one, to make the top entry 0. Okay, I can use this row to make this 0. Why I have to make it 0? Because this matrix is row equivalent to B, and in the B matrix the topmost entry is 0. So that's why I'm planning to make it 0. How can I make it 0? It's very easy. You can check. This one is 6 minus some number times this number. What should I put here? So you can easily guess, if I put here 6, then I will get 0. Okay. So this number 6 comes from row 1. So that means here I will write R1 minus this comes from the constant, which is 6, and this 1 comes from here, row 2. So that means I will apply this operation, right? So in R1 will be replaced by this operation. This operation is R1 minus 6 times R2. So first of all, I have written the same matrix A here, and in the first row will be replaced by this. The first row will be R1. I have written R1 as it is, but I have minus 6 times R2. So I will write minus 6 everywhere times R2 times, what is R2? R2 is 1 times R2 here is 1 times R2 here is 2. Okay. Now the first row has been changed, just like this operation. Now if I will simplify, I will get, after simplification, this matrix. Okay. Now again look at the matrix B. The matrix B is this one. You can check the first entry of the first row and the first entry of the first row of A are same. The first entry of the second row and the first entry of the second row of A are same. But the last entry are not same. So here it should be 15. How can I make this 15? That means if I add 5 here, then it can be 15, right? So that means I should write 10 plus 5 times this one. In other words, this 10 refers to R3. Okay? This 10 refers to R3 plus this 5 refers to scalar and this one refers to R2. Okay? So that's why I will write R2 here. Okay. I will apply this operation and this operation will be performed in row 3. Okay? That means the first 2 rows will be unchanged. So the first 2 rows are unchanged and the last row is replaced by R3 plus 5 times R2. And the last row is R3, 10 minus 5, 6. You can check 10 minus 5, 6. But I have to add 5 everywhere. 5 times R2 times this is R2 times this is R2 times this is R2. Okay, this is the operation which I have performed. And after simplification, I will get this matrix. Now if I compare this matrix to the matrix B, I will get that this 0 and this 0 are corresponding to each other. There is no change in this entry, no change in this entry, no change in this entry, no change here, no change here, no change here. What's left? That means the things which are left must be same. What does that mean? That means negative 4 must be equal to x now and 16 must be equal to y. So I will write, by comparing these terms, x must be equal to negative 4 and y must be equals to 16. And this is all.